So this question says, prove that the surge function f of t equals a times t times e to the power of negative bt, where t is bigger than or equal to 0, a is bigger than 0, b is bigger than 0, has a point of inflection at t equals 2 divided by b. So number one, the surge function it looks actually something like this if you were to graph its shape. And usually actually typically we only care about positive values for the surge function. This surge function actually is a function that's used to model how a drug is administered, like the concentration of drug that's administered in the bloodstream after a patient gets like a dose of a drug. So it kind of resembles, like it has like a spike and then it kind of tapers off. So anyhow, that's just an application of it, but something maybe some of you might want to explore for your IAs or something. So here you have a function. First thing that trips people up, okay? There are no x's, okay? I know there are no x's, but t here is the independent variable, and you need to be able to recognize that. As HL students, you have to be able to separate the variables, the independent variables, from the constants, okay? So t here is the independent variable. F of t is your dependent variable. So the only things that are changing or varying are the t inputs and the f of t outputs. This a and b are just constants. Now, I know it doesn't look like that, okay, maybe because we represent constants and variables with, letters, but it's one of those things you kind of have to wrap your head around. You have to separate the constants from the variables. To do that, one thing you could do is just let a be 1 and b be equal to 1. If you do that, you get a function f of t equals t e to the power of negative t, okay? And you get probably one of the simplest examples of a surge function. But a and b are just constants. They're positive constants. They're just constants. You have to treat them like constants, okay? We have to somehow prove that the surge function has a point of inflection at t equals 2 over b. Because they're asking us for proving, or they're asking us to prove that there's a point of inflection, we need the second derivative. So first we need to find the first derivative, and then find the second derivative. I'm going to treat the at as my first function, okay? So I'll say this is my first function, and then I'm going to treat the e to the power of negative bt as my second function, okay? So I'm going to separate it that way. Okay, here I'm going to apply the product rule. Just be careful. The a here is a constant, so maybe it's like 1 or 2. If a was 2, the derivative of the first function would just be 2. So the derivative of capital A times t is just a, okay? Because this a is just a constant. It's describing the slope of at. So the derivative of at is just a times the second function. Second function is e to the power of negative bt plus the first function. First function is a times t times the derivative of the second function. Derivative of the second function is e to the power of negative bt times the derivative of, with respect to t now, of negative bt. Okay, so the derivative with respect to t of negative bt is just going to be negative b. Okay, so let's not forget that we're multiplying by negative b there. Okay, all right, so I'm going to simplify a little bit and then we'll group. Okay, so we get negative a b t e to the power of negative bt. Okay, next what you have to do, our eventual goal is to prove something about a point of inflection. At a point of inflection, the second derivative is 0. We're probably going to want to keep things in factorized form. I guess it's up to you how you want to take the second derivative. I think I'm going to start factorizing from now. So if I factorize, I notice an a is common. I also notice e to the power of negative bt is common. So you get 1 minus bt. Okay, and now we need to take the second derivative. Okay, so we take the derivative of this. This is just a constant. Okay, derivative of e to the power of negative bt is e to the power of negative bt times negative b. Okay, so I'm going to do a times e to the power of negative bt times negative b, that's applying chain rule, times the second function plus the first function. Okay, so I'm calling this to be the first function now, plus the first function, times derivative of the second function. The second function here is just a line with a slope of negative b, so its derivative is going to be negative b. Okay. Just hang in there. I know it's a lot of algebra, but just kind of carefully go through the algebra. So we're, after simplifying, we get negative ABE to the power of negative BT times 1 minus BT minus ABE to the power of negative BT. Okay. And I'm going to factor out a negative sign, I think, because that's common. Factor out an A is common, and then factor out a B is common, and then also a E to the power of negative BT, that's common. So actually, I'm going to factor out basically everything. Okay, after you factor out, this entire thing goes into this once, and so what you're left with after you factor out that, you just get 1 minus BT. And then this entire expression goes into this entire expression one time, okay? But there's, just be careful here, actually. There's oh no, actually it'll be a +1, yeah. Okay, so it'll be +1. Okay, so that was the first term, and then that's the second term after the factorization. Next, what I'm going to do is combine the 1 plus 1 is a 2. And get 2 minus BT. Okay, it's nice. It's in factorized form. What we need to do is we need to prove that the point of inflection is at t equals 2 divided by b. Somehow we have to arrive at this as our final result. Remember, at a point of inflection, two things have to be true. Number one, the second derivative has to be equal to 0. Number two, the sign of the second derivative has to change around that point of inflection. Okay, so I'm going to set f prime of double prime of t equal to 0. If I do that, I get negative ab e to the power of negative bt times 2 minus bt times equals 0. Okay, now this is the part where this is the thing that I was talking about earlier, is that students who typically do well in math at least achieve like 6s and 7s, and I think that's a very good score. They have an ability to reason about unknown constants even if they don't know what those values are. So here the question tells you that capital A is positive and B is positive, and e to the power of negative bt is always going to be positive. And this is something I talked about last time, non-negative function. Like, this thing's always going to be positive, right? So if this is positive, and this is positive, and this is positive, there's no way this is going to be equal to 0. So it's safe to divide through by this, and also divide through by the negative of it. It's safe to do that. That'll be a non-zero value. Okay, so I'm just going to say that, therefore, this is true. And the reason is, I can say as A is positive, B is positive, and also e to the power of negative bt is also positive. That's why I can just divide through, and it's fine. Okay, if you add bt to both sides, you get bt equals 2, t is equal to 2 over b. Okay, and that's kind of the final result that we're after. Now, if you stop here, you might, you will lose a reasoning mark. The reason you're going to lose a reasoning mark is because to show that something's a point of inflection, it's not enough to show the second derivative is 0. You need to show that the second derivative is equal to 0 at that point. So here it is equal to 0, but you also need to show that there's a sign change around that inflection point. Okay, so what I'm saying is we need to somehow talk about the sign diagram of f double prime. So I'm going to say f double prime has sign diagram. And then I'm going to draw out a sign diagram. Okay, so we'll use a t-axis here. We're not really concerned about values. I believe the t-values are bigger than or equal to 0, so I think I can safely ignore negative values. And b is positive. Okay, so let's keep that in mind. B is positive. If b is positive, okay, then 2 divided by b is positive. We're not sure where that is, but let's say it's here. What you need to do now, and this is what makes it tricky. I'm not saying this is easy, guys. This is a skill that you need to kind of build over time, but you need to be able to reason about these unknown constants, even if you don't know about their values. So one thing you can say, for example, is 3 is larger than 2, and I think that's an uncontroversial statement. And then I can say, well, if b is positive, I can divide both sides by b, right? So like if 3 is bigger than 2, then 3 divided by b should be bigger than 2 over b. So what I'm saying is you can use that to test test the second derivative to the right and to the left of this inflection point. So if we try, for example, 3 divided by b, and let's just say we try 3 divided by b for t. 3 divided by b means that you have 2 minus, let's write this down, 2 minus b times 3 divided by b. Okay, here you're going to get this happening. And these will cancel, and you're left with 2 minus 3, which is negative 1. And you also have this thing, and this thing's always negative. Okay, so, and the reason I know that, this is always negative. The reason I know that's always negative is because e to the power of x is always positive, b is positive, by definition a is positive, and this thing, there's a negative sign here. So this thing's always negative. And this thing, we've just shown that if you plug in a value, like if you test a value, like 3 over b, somewhere here, you plug it into here, you're going to get a negative value out. So a negative here times a negative here is going to give us a positive value overall. Okay, and you can kind of confirm that between 0 and 2 over b, you're actually going to get a negative value out in the second derivative. And so this is the confirmation. So when they say prove, you not only have to kind of demonstrate that at the inflection point, you know, the second derivative is 0, but you also need to show that there's a sign change around the second derivative. Okay, so you can say, well, therefore, double prime of 2 over b is equal to 0, and f double prime of t changes sign. Okay, so therefore t equals 2 over b is an inflection point, and then you're done. Okay, so that kind of completes the proof. Okay, I know that question was difficult. Actually, last year I had the kids do it as a challenge problem, and I do think it's kind of that level where it is kind of challenging, but hopefully you learned something from it. Hopefully you kind of carry this idea of unknown constants forward with you, because you're going to be dealing with them quite a bit the further and further you go. And hopefully this was a good introduction to it. Okay, have a good rest of your day.